To continue from the last lecture, we're going to continue with the disaccharides, and we're going to focus on lactose now. And lactose consists of two monosaccharides, and the first one is the galactose linked with glucose. All right. Now, lactose, as you know, occurs naturally in human and cow milk. It consists of about 5%. That's why it tastes a little sweet. It's made of the galactose and glucose in, let's look at the structure. You should be able to tell me what this linkage, figure out, zoom in on the linkage, which is the anomeric carbon, is 1 to 4, and is this an alpha or a beta? As you can see that it's on the same side as the CH2OH, so it's a beta glycoside linkage. And notice in this picture we don't have a squeaky line. This is drawn as this OH is same side as this once again, so that's beta. So this would be a beta lactose. And as we talked about before, if you were to take the beta lactose and put it in solution, it will, this unit right here will open up and close, so you'll have a mixture of alpha lactose with the beta lactose with a little bit of opened up form. So lactose once again will mutarotate and is a reducing sugar. All right. So in normal human metabolism, lactose is hydrolyzed enzymatically to D-galactose and D-glucose. So this bond right here, we have an enzyme that cleaves that. So we basically take lactose, and then we have an enzyme called lactase. Surprise, surprise. And that cleaves that glycoside bond to glucose and galactose. All right. So those people who lack this enzyme, lactase, are the people that are lactose intolerant. All right. So they can't metabolize lactose because the first step in breaking down the disaccharide to 2 monosaccharide isn't there. But that's not really life-threatening, because you could control with the diet so that you don't suffer the consequences of having lactose buildup in your system. However, if you're missing another enzyme, so our body can't process galactose as it is. It has to have another enzyme that converts galactose into glucose. And people who don't have this enzyme, they are called galactosemia. Let me just write that down. If you don't have that enzyme, they suffer this condition called galactosemia, and that's characterized by high level of galactose. And when an infant is born with this, they might suffer from this condition, and it's very hard to diagnose because it's pretty rare that they are lacking this enzyme, but they will exhibit vomiting, and if it's not treated right away, then they may have mental retardation and sometimes could lead to death. So this is a pretty serious condition, and so it's one of the things that they check if infant is not doing well. All right, so that is the second disaccharide, lactose. And the last disaccharide that we're going to look at is sucrose. And sucrose, as you know, is the table sugar, and this is made up of glucose linked with fructose. All right, and it has a pretty different structure than what you're used to, because the fructose is a ketose, not an aldose. So its structure is carbon 1 is the CH2OH, not an aldehyde, and then second carbon is the ketone, and then it has, you know, various OHs like other sugars. So this is structure of fructose, and it does the same chemistry as other sugars. So when this cyclizes with the C5OH right here, it cyclizes with this C2 carbonyl. Because the carbonyl is in the second carbon now, not on the first carbon, instead of making a 6-member ring, it makes a 5-member ring called furanose. So when it does that, the fructose exists in this cyclized form as you see here, and this is carbon 1 right here, CH2OH, and this is carbon 2, which is the anomeric carbon in fructose, and then this will be C3, C4, C5, and then C6. So it's a little different than what you're used to looking at in a 6-member pyranose type of monosaccharides. All right, so this is typical glucose you've seen before. And notice the glycoside linkage. Okay, so the glycoside linkage is this is the alpha glycoside linkage in terms of glucose. But notice, unlike the other glycoside linkages in which C4 was the alcohol was the one that served as the OH to make the acetal, in sucrose, the carbon 2 or the anomeric OH is the one that serves as the alcohol for making the acetal. So at this center is another glycoside bond. All right, so notice this anomeric bond in terms of fructose. You got one OR, and the second OR is right here, OR. So in terms of fructose, you have 2 ORs at this anomeric carbon, and then as far as glucose is concerned, it also have 2 ORs, right? Do you see that? 1 OR and 2 OR. So in both sugar cases, both monosaccharide, they're at the acetal stage, here and here. All right, so a lot of times it's described, you know, 1 to 2 alpha in terms of the glucose, but then you also have to describe in terms of fructose, which is like 2 to 1 beta. All right, so you're going to see both descriptions, or you might see it as 1 alpha comma 2 beta to describe this both glycoside linkage. All right, so 1 alpha 2 beta is the both glycoside linkage. All right, so in terms of chemistry though, what would you expect sucrose to do? You know, will this mutarotate, since we have 2 acetals, not 1 acetal and 1 hemiacetal? So because we have 2 monosaccharides, both in acetal stage, it's not going to mutarotate. It's pretty stable the way it is in water. And is it going to be a reducing sugar? And you should already know the answer to that. It will not be a reducing sugar because it can't open up and close, so there's no place where it could be oxidized with the mild oxidizing sugar. So those are the questions that you should be able to answer, and at this point you should be able to do 24.39 and be able to given especially for glucose, because you're supposed to know the structure of glucose, you should be able to draw maltose and cellobiose, knowing that you have the only difference is the alpha and the beta, and you should be able to differentiate. If I give you a structure of either disaccharides, or now we're going to go on to polysaccharides, which one is a structure of starch versus which one is structure of cellulose. All right, so that concludes this lecture in finishing up the disaccharides.